Welcome to Department of Electronic Science, University of Pune. We have developed as part FPGA-based reconfigurable data acquisition and analysis system. As you can see, this is a Spartan 3 starter kit. ADC is used. The channel B of an ADC is used for data acquisition purposes. The function generator of let's say 100 kilohertz signal is provided from function generator to an ADC. A serial port over here is used for a data transfer from host PC to a target and from target to an host PC. Live view based GUI for the testing purposes of this reconfigurable data acquisition system. As you can see, this is the port selection for the COM port. This is a block for the selecting and sampling frequency and the number of points for the FFT. This part is used for the reconfiguration. So let's see a quick demo of the system. Now first reset the system. Now choose whatever the sampling frequency and number of points that you want to configure. Now here the 350 kilohertz is the sampling frequency and number of points are chosen to be 512. After choosing these things, please click on a send button. You will see a light which is glow over here, which indicates the data acquisition process is completed. Now click a button which latches the whatever the reconfiguration to your hardware, and then press this button so that FFT is computed. Now to see a time domain or a sample data, you have to click on input data button from GUI. Now from hardware you select a button slide upside so that you will choose input memory data for the to see that data on the host PC. Now this button will actually throw all the sample data to a serial port so that one can see that data on your host PC. Now you can see the data is appeared on this GUI part. This is a sample data in a time domain signal. Now we will see how we can see the FFT on your GUI. Now to see a GUI, the FFT, please select button load from a GUI. Then select this switch as an upside and select your output memory, that is an memory which is having FFT data. Now use this button so that you can throw that data to the serial port. Now once you send that real data to a serial port, now you have to actually load imaginary part also, because an FFT is having both the real part and imaginary part. Now to select a memory which is having an imaginary part, you have to select this switch upward. Now again we have to send that data to a host PC, so we have to give a high to low transition. Now imaginary data is also loaded on the from the serial port to an host PC and computation is done. Now click a graph plot button from a GUI and you can see that immediately that FFT is appeared on your GUI. Now here is you can see a marker is there, and if you put that marker on the highest peak of the whatever the graph chart is there, so you can see the in this window particularly you can see the frequency which is showing 1.05 into the 10⁻⁵. That means the 100 kilohertz frequency, which is you can see that is an input frequency which we given from our signal generator.